video is going to cover rates of reaction, or how can we make a reaction between two chemicals faster. So for any reaction to happen between two substances, the particles within those substances must collide together. So just in this example, for my orange and my purple particle or chemical to react, they must collide together, and they're going to make, in this case, something like that. Okay, so we've got to have a collision between these two particles. Now, if it is a head-on collision with lots of energy, they are likely to react together and have enough energy to combine and react. However, if they do not collide in the correct orientation or in the correct direction, you might get a glancing blow. There might not be enough energy to make them react. They might just bounce off each other. So therefore, there are two key principles that we need to talk about in these questions about how to make reactions as fast as possible. And they are, one, the energy of the collisions. So when particles collide together, do they have enough energy to cause a reaction? The second is the frequency of the collisions. Okay, if you have a bucket and you're going to have billions and billions of particles in there, all moving around, all colliding together, if you can make collisions between the particles you want to react together more frequent, then there are going to be more successful collisions every second, so the rate of reaction will be higher. So these are our two key ideas that we need to talk about in these questions. Now, there are 4 ways we need to know about which will allow us to change either the energy or the frequency of collisions or both. So I'm going to divide up my page into 4. And the first one we need to know about is temperature. So, if you imagine in my sample I've got a certain number of particles and they all move in quite slowly. Okay, so these particles are moving, but they're moving around relatively slowly. They are going to collide together, but there is not going to be much energy, and they are not going to collide together very often. There will be a low frequency of collision. However, if I start heating this mixture up, I'm going to start making my particles move much faster. What this is going to do is have two effects which will increase the rate of my reaction. The first one is that the energy of those colliding particles will increase. So now, if this purple one were to crash into that green one there, it would collide with a lot more energy. It would be more likely to cause a reaction. Not only that, but the frequency of collisions is going to increase as well. So if I increase the temp, I'm going to increase the frequency of collisions. I'm going to increase the energy with which those collisions, so I'm going to increase the energy of those collisions, so the rate of reaction will also increase. The second factor we need to know about is the concentration of our chemicals I have. So similar idea again. I'm not going to show arrows on this time, but just imagine I've got a sample, and I've got my purple particles. I've got green ones. Okay, and these are in a fixed volume. So let's draw these inside a container. Okay, these are all going to be moving around. They're going to collide together, but they are not very concentrated. Therefore, the frequency of the collisions is going to be quite low. If I were to increase the concentration of these chemicals now, so I've got many more particles in the same volume. Okay, there is much less space between these particles now, between the particles I want to react. Therefore, every second, there are going to be many more collisions between the particles. So if I increase the frequency, if I increase the concentration, I'm going to increase the frequency of collisions. And therefore the rate of reaction will again increase. Oops. The rate of reaction will increase. Note that this time I am not making the particles move any faster. I do not actually increase the energy, I just increase the frequency, but that will still increase the rate of reaction. Okay, number 3 that I'm going to talk about is actually just for solids, and this one is the surface area. Okay, so in this case, I'm going to have a solid, and I'm going to imagine I've got a very large block of something like limestone. I'm just going to draw a single large block of limestone. If I put it in acids, the acid particles are going to collide with the surface, and I'm going to get a reaction happening whenever particles collide with the surface with enough energy. Okay, so whenever one of these particles hits the sides of this block, I'm going to get a reaction. Okay. However, I can increase this rate of reaction if I keep the volume of my solid the same, and I can do it by increasing the surface area. So if I simply split this block up into 4 smaller squares, I'm going to keep the overall volume the same. So the mass of this solid will be the same as this one, but I've just either ground it up or ground it into smaller sections. Now, if you think about it, there is a much higher surface area where these particles can collide. Okay, so we can get collisions here, we can get collisions here now. So there is a much larger surface area. So there are going to be the collisions are going to be much more frequent. Okay, so in this one I have increased the surface area. Therefore, I haven't increased the energy of the collisions, but I have increased the frequency of them. And therefore, my rate of reaction will once again increase. Okay, the final one that we need to know about for our exam is the use of a catalyst. And you don't actually need to know in masses of detail how this affects the reaction. What you do need to know is that a catalyst is a substance that speeds up a chemical reaction. That should be a D. Speeds up a chemical reaction without being used up. So what actually happens is that your catalyst is normally a solid, although it doesn't have to be, and it provides a surface where your reacting particles can collide with it, or adsorb on, or stick to, and it provides a surface for the reaction to take place on. It lowers the amount of energy that is needed for the particles to react. And the example we really need to know for our exam is a catalytic converter in a car. Okay, so if I were to really zoom in on a catalytic converter in a car, you would actually see something like this. So you would see a big block of, it's actually a ceramic substance, but with a coating of platinum or palladium or rhodium. And you would see that the surface is honeycomb like this. So it's a block with where air can flow through, but it is honeycombed in this. And on the surface of all of these, little sections here, you've got your catalyst coated in here. Okay, so in every single one of these blocks, you've got catalyst coating the surface. And what this does is it provides an extremely large surface area for the reaction to take place on. So you've got catalyst coating all the surface, a very large surface area. So there are lots of places where the chemicals can stick to or absorb on, where the reaction can take place. Not only that, but your catalytic converter is placed just after the engine. This means the exhaust fumes that pass over it are extremely hot, which again further increases your rate of reaction. Now, the point of a catalytic converter, why we have them in cars, is to break up, to remove any unburnt fuel, and to remove any carbon monoxide. It actually does several other jobs as well. It reduces the amount of sulfur dioxide that cars give out. But the two that are on the spec for the exam, the catalytic converters break down or remove any unburnt fuel and carbon monoxide, and it turns them into carbon dioxide and water, H2O. So quick recap then, we've got 4 factors that can speed up either the energy of collisions between particles or the frequency of those collisions. The first one, temperature. Increasing temperature makes the particles move faster, so which increases the frequency of collisions and the energy of them. If you have more particles in the same volume, you increase the frequency of collisions, so increasing concentration makes the rate of reaction faster. If you grind up a solid or make the solid into smaller pieces, you increase the surface area, which increases the frequency of collisions and the rate of reaction. And finally, a catalyst, such as a catalytic converter in a car, will convert unburnt fuel and carbon monoxide into less harmful products. Catalytic converters have a very high surface area and they have a high temperature, and they provide a surface where the reaction can take place.